Hello and welcome to today's webinar on the discovery of insulin, which revolutionized the treatment of diabetes. And we're also coming up on the 100-year anniversary of the discovery of insulin. So before insulin was available as a treatment, diabetes invariably led to death. And it was thought that dietary interventions, such as the use of hypercaloric diets, would be a useful treatment for diabetes. The idea was to try to compensate for metabolic impairments. However, caloric excess did not improve the symptoms. And astute doctors started to notice that quite the opposite, fasting actually improved symptoms. So leading specialists in the field at the time were doctors Frederick Allen and Elliot Joslin. So from about 1915 onward, starvation diets were prescribed. And these extended life expectancy to some degree and also relieved the symptoms of diabetes. However, some patients died of starvation. And here's a quote from Dr. Joslin. "We literally starved the child and the adult with the faint hope that something new in treatment would appear. It was no fun to starve a child to let him live." So the real idea behind these starvation diets was just really to try and buy their time until a better treatment came along. So we're going to be learning about the major players in the discovery of insulin. So these major players included Frederick Banting, John Macleod, James Collip, and Charles Bess. And insulin was discovered here at the University of Toronto. Frederick Banting was born in 1891 in a farmhouse near Alliston, Ontario. And there's a picture of the childhood home of Frederick Banting. He enrolled in Victoria College at the University of Toronto, and then he transferred to medical school in the fall of 1912. He then enlisted in the Canadian Army in World War I, and he ended up finishing med school in 15 months. And he worked as a medical officer in England, and in 1919 he was awarded the Military Cross for heroism. After the war, Frederick Banting became a surgical resident at Sick Kids Hospital here in Toronto in 1919. He then opened up a surgery practice in London, Ontario. However, this surgery practice experienced limited success. So he then went on to get a lectureship at the University of Western Ontario, where he taught courses between 1919 and 1920. He also lectured in the Department of Pharmacology at U of T from 1921 to 1922. In addition to his achievements in surgery and science, he was also an accomplished painter. And here's a picture of one of his paintings entitled The Lab, which Frederick Banting painted in about 1925. So what was known by 1920? The islets of the pancreas were first described by Paul Langerhans in 1869, and the importance of the pancreas in carbohydrate metabolism was established in 1890. And in 1890, two scientists, von Mering and Mikowski, removed the pancreas from a dog and noted that that produced severe diabetes and especially high blood sugar. And these are similar to the experiments that Banting and Bess conducted at the University of Toronto 30 years later, which we'll talk about. The islet tissue was thought to be responsible for the internal secretion that regulated blood sugar, and this was discovered in about 1894. The word hormone was coined in 1905, and the word insulin was coined a few years later in 1913. So many scientists had already found that pancreatic extracts reduced high blood sugar or glycosuria in experimental animals. And some work had even been done in humans, but lots of toxicity was noted. Some papers had even been published in the area, but the importance of the work was really not fully recognized by the medical community before 1920. George Ludwig Zwalzer was a German scientist who in 1906 to 1907 injected 8 mils of pancreatic extract subcutaneously into a patient who was experiencing a diabetic coma, and he noted that the patient improved. So here's an early example of some experiments that were performed in humans using pancreatic extract. Subsequent treatments of some patients ended up producing seizures due to hypoglycemia. And this is because no technology was available at the time to measure blood sugar. So what was happening was they were injecting too much of this extract. E.L. Scott was an American, and in 1911, he administered pancreatic extracts to dogs with surgically altered pancreas, leading to a lowering in blood sugar levels. But he was only a master's student at the time, and his thesis advisor unfortunately discouraged him from continuing his work. So these are just two examples of the scientists that were working in this area prior to 1920. In October 1920, while he was preparing to give a lecture at the University of Western Ontario on the pancreas, Frederick Banting read an article by Moses Barron entitled "The Relation of the Islets of Langerhans to Diabetes," with special reference to cases of pancreatic lithiasis. And this was published in the journal Surgery, Gynecology, and Obstetrics. So when we're talking about a pancreatic lithiasis, we're really talking about a pancreatic stone. And in this particular case, the pancreatic stone was completely obstructing the main pancreatic duct. And what happened was all of the exocrine cells, which produce digestive enzymes, including those that digest peptides like insulin, had atrophied because of this stone. But the islet cells, the ones that secrete insulin and other hormones, had survived intact. And the author of this article, Barron, had pointed to the literature where similar findings had also been observed when the pancreatic duct was ligated. So this famously led to an aha moment that Banting experienced early in November 1920, in the middle of the night. His idea was to ligate pancreatic ducts of dog, keep the dogs alive till the acini degenerate, leaving the islets intact. Try to isolate the internal secretion of these to relieve glycosuria. So to recap, Banting suspected that the pancreatic juice contained some substance that was destroying the hormone secreted from the islets of Langerhans. If he could prevent this destruction, he should be able to successfully isolate this blood sugar lowering hormone. Ligating the pancreatic duct caused the exocrine cells to atrophy, which greatly reduced the impact of digestive enzymes. Therefore, insulin remained intact. The second key player in the discovery of insulin was John James Rickard Macleod. So F.R. Miller, who was a scientist at the University of Western Ontario, suggested to Frederick Banting that he should bring his idea to J.J.R. Macleod at the University of Toronto. Macleod was born in the UK in 1876, and he was an expert in carbohydrate metabolism. He was a professor of physiology as well as the head of this department at the University of Toronto, and he published a book, Diabetes, Its Pathological Physiology, in 1913. So 3 visits took place between Banting and Macleod at the University of Toronto, and these began in November 1920, after Banting had had his aha moment. But Banting really did not have a ton of knowledge or experience in the field of carbohydrate metabolism. But to his credit, he did show a lot of persistence and enthusiasm. Macleod believed that ligating the duct was worth trying, and he eventually offered lab space to Banting. Macleod also offered the help of 2 research assistants, Charles Best and E.C. Nobel. And I really like this quote from Frederick Banting, which might explain why he didn't have a ton of background knowledge in the area of carbohydrate metabolism. He said, "Too much reading of the literature is inadvisable for the wide diversity of opinion and confusion of thought." Charles Best is the 3rd player in the discovery of insulin. He was born in 1899, and he trained in physiology and biochemistry. So along with E.C. Nobel, he was a research assistant. And there is some evidence that Nobel helped Banting when Best went away on holiday. So Best began to work with Banting in May of 1921 based on a coin toss. So it's said that Charles Best and E.C. Nobel flipped a coin to see who would start working with Banting first on these experiments, and Best won this coin toss. So Macleod left about 1 month later for Scotland for his summer holiday after supplying 10 dogs. And there's a picture of Banting and Best around 1924, so a few years after the discovery of insulin. So here's an overview of the experimental procedure. Ligate the pancreatic duct, remove and process the atrophied pancreas, extract the internal secretion, administer this internal secretion to depancreatized diabetic dogs. And the specific role that Charles Best had in these experiments was to obtain blood and urine samples to determine the levels of sugars. So here's a diagram showing what we just talked about. So they started with healthy dogs that had a healthy pancreas. So both the islet cells or the endocrine cells that secrete hormones were intact, and the exocrine cells were also intact. And they ligated the pancreatic duct, which led to the atrophy of the exocrine glands. But you can see in that little cartoon that the islet cells are still intact. They then extracted the pancreatic extract, and they administered this to dogs that they had removed the pancreas from. So these dogs had developed diabetes. So in the group 1, the treatment group, these dogs with diabetes received the pancreatic extract, and they ended up being cured. They had a second group, a control group, that received no treatment. And these dogs with diabetes ended up remaining sick because they did not receive the pancreatic extract. So in terms of some of the initial experimental results, unfortunately, the lab was not really well equipped for surgery, and many of the original dogs had died due to infection. But at the end of July, a depancreatized dog and a duct-tied dog were ready. The pancreas from the duct-tied dog was removed, processed, and placed in a special solution. The extract was then filtered, warmed to body temperature, and administered to the depancreatized dog that had diabetes. And they noted that the blood sugar fell substantially from 0.2% to 0.1% in about 1 hour. They noted that the effect was of short duration. The significance of this was that this was the first evidence that Banting and Best had an anti-diabetic extract. So as with any experimental approach, you want to tweak it to help optimize it. And in August of 1921, they ended up performing a complete pancreatectomy at the initial operation. So they skipped the duct ligation altogether. They noticed that within this dog, the blood sugar decreased from 0.3% to 0.17% 1 hour after the injection of pancreatic extract. But the dog started to weaken a couple of days later. So they stimulated a pancreas with secretin, which helped to exhaust the exocrine function. And the extract from that pancreas was obtained. They gave it to the dog, and the dog ended up rallying. So it really turned out that the work with the duct-tied dogs was not necessary. I really like this cartoon here, which says, "This is the Institute for Advanced Hindsight, research into what should have been." In autumn of 1921, Macleod returned to Toronto. The encouraging results from the studies were met with some skepticism. So Macleod really thought, is this too good to be true? And he decided it was best to repeat the experiments before the purification steps. And it's always a good idea with any sort of research project to repeat your experiments to make sure your results are true and robust. Macleod also suggested that they needed to do a hemoglobin quantification to rule out a dilution of blood volume effect. So could the glucose concentration be dropping simply because of the volume of fluid they were injecting? So this is something that they also needed to check. After Macleod made these suggestions, Banting requested a salary. So up until this time, he hadn't been receiving a salary for this work. He also wanted a separate room to work in, staff to help him care for the dogs, as well as repairs to the operating room floors. Banting ended up receiving an appointment in the Department of Pharmacology at the University of Toronto, and he added a biochemist, J.B. Collip, the fourth major player in the discovery of insulin, to the team. Collip's role was to help improve the pancreatic extracts. And they also experimented with fetal pancreas, which is free from these destructive enzymes. So here's some graphs of their early findings. In the top panel A, this is showing the first dramatic lowering of blood sugar by insulin. So on the x-axis, is the time of day, and on the y-axis is the blood sugar concentration. And each of those little arrows is showing an injection of 8 mils intravenously of the pancreatic extract. And then you'll see over time that the blood sugar concentration is dropping with subsequent injections. In panel B, on the bottom left, you're seeing the first production of hypoglycemia by insulin. So in this particular case, they injected a larger volume, 30 milliliters intravenously of this pancreatic extract, and they noted hypoglycemia. In panel C, on the top right, you're seeing the first alleviation of this hypoglycemia by the administration of sugar. So what you're seeing is a series of pancreatic extract injections. So the blood glucose level is dropping, and then they administer glucose, indicated at that time point circled in red. And you see that the concentration of, or the blood sugar concentration is increasing. And in panel D, you're seeing the lowering of blood sugar by extract from fetal calf pancreas. So they also did some experiments with fetal tissue because it is free of the destructive enzymes. Banting and Best's work was first presented at the Physiological Journal Club at the University of Toronto on November 14th. When Banting and Best were presenting, Macleod interjected a few times and ended up speaking very eloquently. In contrast, it was said that Banting appeared quite nervous when he was presenting, but Macleod was eloquent. And Macleod also used the term "we" when he was describing the work, which made Banting a bit frustrated because he felt that he and Best had done a lot of the work themselves. So this is a great lesson for any collaborative science project where it's very important to discuss roles and even authorship on the future papers that will result from the work before the work even begins. The first public presentation outside of U of T occurred at the meeting of the American Physiological Society in New Haven, Connecticut on December 30th, 1921. And at this meeting, Macleod intervened during the discussion, and Banting again felt a bit frustrated. George H.A. Klaus, a research director at Eli Lilly and Company, was in attendance, and he asked to collaborate with the Toronto group to prepare the extract commercially, so he was very excited by the results he was seeing. Macleod cautiously emphasized that the extract was still premature and quite crude, and it needed further work in purification. So here's the first publication, The Internal Secretion of the Pancreas, by authors Banting and Best, and this was published in the Journal of Laboratory and Clinical Medicine in 1922. And these are showing the original graphs, which were hand-drawn, and what they're showing is a series of experiments that took place in July. So on July 11th, they removed a pancreas from a dog. They gave dextrose on July 27th, so circled in that red color there in the middle. And what they noticed was that the blood sugar concentration went up. And then on July 30th, in the right-hand side of the graph, again circled in red, they're giving the extract. And what you can see is that the blood sugar concentration is decreasing. So in this particular graph, the level of blood sugar is shown in the solid black line. Now, you don't have to memorize any of this. I just want to give you a bit of an idea of the number of different combinations that they tested and some of the controls as well on the next couple, on this slide and the following slide as well. So again, they tried a number of different preparations of the extract. They tried it with 0.1% HCl. They tried it with 0.1% NaOH. They tried a whole gland extract with and without hydrochloric acid and NaOH. And what you're seeing here is that, so number 3, if we just take a look at that one, this is degenerated pancreas. We're looking at the bottom left-hand side, plus 1.1% HCl. And you see a nice lowering of the blood sugar after this extract's given. When you look at the next preparation, which was with NaOH, you notice that there's a little bit of a decrease, but not as pronounced as what they saw with HCl. So again, here's a number of other combinations that they tested. They also tried a unique an interesting experiment, number 10, where they gave the extract, but they administered it along with pancreatic juice. And what you'll notice is that the blood sugar level actually went up a little bit. And this is because the pancreatic juice contains those digestive enzymes that would have been destroying the insulin. And then the next experiment they tried was the exhausted gland extract, but without pancreatic juice. And you'll see a nice lowering of blood sugar here. And they also experimented with pancreatic tissue from other species, such as cat. So in conclusion, the authors said intravenous injection of extract from dog's pancreas removed from 7 to 10 weeks after ligation of the ducts invariably exercises a reducing influence upon the percentage sugar of the blood and the amount of sugar excreted in the urine. So they tried other routes of administration as well, such as rectal administration, and they noted that this was not effective. They noted that the extent and duration of the reduction varied directly with the amount of extract injected. So they had a nice dose-response relationship there. More extract meant more lowering of blood sugar and sugar in the urine. In that experiment with the pancreatic juice, they also noted that this would destroy the active principle of the extract, so it didn't work. They noted that the extract made with 0.1% HCl was effectual in lowering the blood sugar. So it seemed that when they combined it with acid, it worked better than when they were combining it with a weak basic solution. The presence of extract enables a diabetic animal to retain a much greater percentage of injected sugar than it would otherwise. They also noted that when the extract was prepared in neutral saline and if they kept it in cold storage, it tended to retain its potency for at least a week. They noted that boiled extract had no effect on the reduction of blood sugar. And this is because boiling would have destroyed insulin, which is a peptide hormone. They tested a number of controls, some of which we already talked about. They also tested extracts from other tissues and found that they did not produce this lowering of blood sugar. So these are some really nice negative controls that they tested. And they also measured hemoglobin level to rule out a dilution effect. And that was one of the earlier suggestions that Macleod had made when he came back from his summer holiday. So the fourth major player that we introduced a little bit earlier is James Collip. He joined the team in December 1921 while on sabbatical. And he was a Canadian biochemist at the University of Alberta. And he had performed similar experiments in rabbits. In depancreatized dogs, he had observed the storing of glucose as glycogen in the liver following the administration of pancreatic extract. So he had done some work in dogs as well as rabbits. In January 1922, he worked to improve the purity of the pancreatic extract and eventually was able to remove most of the contaminants. So up until this time, the pancreatic extract was not ready to be administered to humans. Further work needed to be done. He used normal rabbits as a means to help assess the potency of the insulin used in initial clinical cases. And he discovered that the hypoglycemia induced in the rabbits that were treated could be alleviated by the administration of glucose and adrenaline. So this brings us to some early attempts in the clinic. So the first patient with diabetes to be injected with this extract was Leonard Thompson. And at the time, he was a 14-year-old boy with severe diabetes who weighed only 65 pounds. And when he received this extract, his blood sugar dropped from 0.44% to 0.32%. But unfortunately, an abscess developed at the site of injection, which really suggested that the extract, although it had been purified to some extent, required even further purification to remove the contaminants. Nevertheless, the Toronto Star approached Macleod, and they were really excited by these findings. And Macleod stressed the preliminary nature of the data. So he was always very cautious and saying that further work needed to be done before insulin was ready for prime time. This article was published in mid-January. So up until this time and throughout these clinical experiments as well, there was a number of challenges in the lab. So there was often poor communication. We talked a little bit about how when you have a lack of clearly defined roles up front, that can create issues later on. Full transparency is really needed in collaborative work, so it's really a great idea to map out who's going to work on what and follow through. And personality differences and disagreements can often harm teamwork. And this is not just true for this massive research project, which led to the discovery of insulin, but is true for all projects in science. But despite these challenges, clinical successes started to happen. So treatment resumed on Leonard Thompson on January 23rd. Collip had created a more purified extract using alcohol, so it had fewer contaminants. And they noted that with daily injections, Thompson's blood sugar dropped. He felt better, he felt more lively. And this marks the first success of the extract in humans. 6 more patients were treated the following month, and the doctors Campbell and Fletcher led these clinical studies. The daughter of the governor of New York was named Elizabeth Hughes Gossett, and she had developed diabetes in 1919 at age 11. And she had been previously treated by Dr. Allen, who administered those starvation diets that we talked about earlier. So she was only receiving about 500 calories a day. And her mother contacted Banting, and they came to Toronto in the summer of 1922 to be a subsequent patient to receive the extract. And they noted that her health greatly improved. So this paper, Pancreatic Extracts in the Treatment of Diabetes Mellitus, was published in the Canadian Medical Association Journal in 1922. And the authorship list was Banting, Best, Collip, Campbell, and Fletcher. And this is really a extensive study of Leonard Thompson, the first patient that received this extract to treat his diabetes, and it's an excellent clinical paper. And Banting and Best, up until this time, had provided the extract themselves for these clinical studies, and large amounts were required. This presentation, entitled "The Effect Produced on Diabetes by Extracts of Pancreas," formally announced the discovery of insulin and its therapeutic success to the world. So this presentation was given at the meeting of the Association of American Physicians in May of 1922. Summarized all of the work completed to date, including the clinical. It used the term insulin for the first time, and Macleod presented the work. Banting and Best did not attend the meeting in Washington. So like I mentioned, this formally announced the discovery of insulin. This led to a partnership with Eli Lilly. So attempts to produce insulin in large quantities had failed, and the team at the University of Toronto, Banting and Best, really needed a lot of help to scale up. Best and Collip traveled to Indianapolis and taught the Lilly chemists their method. But they noted some problems with potency, which ended up varying by about 25%. And this was because of dosing issues, because it turned out that Toronto and Lilly were using different sized rabbits to test their potency. They also noted that insulin was being precipitated at the wrong pH. So the senior chemist at Lilly, George Walden, got involved and adjusted the pH to achieve maximum precipitation. Collectively, these efforts resulted in the most stable and potent insulin produced to date. In January of 1923, an American patent was awarded to Banting, Collip, Best for insulin. And Banting, Collip, and Best ended up selling the patent to the University of Toronto for $1 each, because they firmly believed that discovery belonged to the world. And the ability to now make a non-toxic extract was really the key. This led to Colonel Albert Gooderham, the member of the Board of Governors and the chairman of the Insulin Committee, requesting a unified account of each person's contributions to the discovery of insulin. So he essentially asked the question, who did what? And this proved to be a very difficult exercise because they were trying to sort out contributions after the fact. So Banting really believed that the idea was his alone. He remembered Macleod as being highly critical, and he didn't really remember his helpful suggestion. In contrast, Best gave Macleod much more credit and confirmed that it was Macleod who suggested alcohol as an extraction agent. Macleod is quoted as saying, "I gave Dr. Banting full credit for suggesting the experiment of using extracts of duct ligated pancreas and for successfully carrying it out with Mr. Best's collaboration, but this did not imply that I gave these gentlemen complete credit for the discovery of insulin, as now used in the treatment of diabetes. This has depended on the conjoint efforts of several investigators working under my direction, of which Dr. Banting was one. So Macleod really noted that it was a collective effort. This led to the awarding of a Nobel Prize. So the Nobel Prize in Physiology or Medicine in 1923 was awarded to Banting and Macleod. Banting ended up sharing his monetary prize with Best, and Macleod ended up sharing his monetary prize with Collip. So with Nobel Prizes, you're allowed 1 to 3 awardees in total, so should Best have also been included? Collip humbly stated that anyone with biochemistry training could have performed the purification work. And if you'll remember from earlier in this webinar, we learned a little bit about other scientists who had worked in this area prior to the discovery of insulin, some of them in the early 1900s and some of them even as early as 1890. And some of these scientists felt really frustrated. And the Nobel Committee ended up receiving a letter from George Welser, a German scientist that we talked about, and E.L. Scott called attention to his prior work as well. So that was the American master's student who was working in carbohydrate metabolism. Here's an excerpt from the presentation speech, which really acknowledges that there was some preliminary work that had been done in this field prior to this big discovery of insulin. It could be prophesied with a very great degree of probability that such a substance as insulin someday would be produced from the pancreatic gland, and much of the work had been done beforehand by previous investigations, several of whom very nearly reached this goal. Consequently, it has also been said that its discoverer was in a preeminent degree favored by lucky circumstances. Even if this be so, yet there would seem to be cause to remember Pasteur's words, "Chance favors the prepared mind." So let's talk a little bit about life after insulin. Dr. Banting went on to publish in a number of different areas. However, few of his papers had any large impact and none were related to insulin. He was knighted in 1934, and a few years later he became a wartime medical research expert on aviation medicine. And he died a couple years later in a transatlantic plane crash from Newfoundland to the UK. Dr. Macleod became a pioneer of physiology. He wrote over 200 papers, multiple books and chapters, and he was a member of the Royal Society of Canada. He was also president of the American Physiological Society and a member of the Royal Society after 1923. In 1928, he returned to his alma mater, the University of Aberdeen, as a Regius Professor of Physiology, and he later became the Dean of the University of Aberdeen Medical School. Dr. Charles Best became a very accomplished scientist in his own right. In 1925, he earned a medical degree from the University of Toronto. He became a professor of physiology 3 years later at U of T. He was elected a Fellow of the Royal Society of London, and he also became head of Banting and Best Department of Medical Research in 1941. He was repeatedly nominated for the Nobel Prize for his work with choline, insulin, and his general achievements in physiology and medicine. And in 1972, the Nobel Committee acknowledged their error in the Banting and Macleod nomination. So if you remember, we talked about how 1 to 3 awardees were allowed for each Nobel Prize, and they only gave it to Banting and Macleod at the time. So here the Nobel Committee formally acknowledged their mistake. They should have also nominated Best. Some of his notable work included experiments on the effects of choline, and he also isolated and developed heparin. James Collip also became a very accomplished scientist. He was involved in the isolation of parathyroid hormone, and he characterized its role in calcium homeostasis. He also earned a medical degree from the University of Alberta, and he became chairman of biochemistry at McGill. And he did a lot of work on the isolation of ovarian hormones, gonadotropic and adrenocorticotropic hormones, and was involved in their study. He's well known for his pioneering work in endocrinology, and he was really considered a jack of all trades because he studied a wide variety of different hormones. He did work with the pancreas, the parathyroid gland, ovarian hormones, gonadotropic hormones, as well as adrenocorticotropic hormones. So let's talk a little bit about insulin and diabetes management today. So over 34 million Americans currently have diabetes and 88 million have pre-diabetes. The vast majority of cases of diabetes are type 2 diabetes, but about 5 to 10% of patients with diabetes have type 1. Almost 90% of those diagnosed with diabetes are either overweight or obese, and diabetes collectively costs the United States about $327 billion annually in terms of total direct and indirect costs. Insulin remains a mainstay of treatment for patients with type 1 diabetes, and it's also indicated in some patients with type 2 diabetes. And early on, patients with type 2 diabetes can be adequately managed with lifestyle changes in some cases, such as healthy diet and regular exercise. And there's also numerous drug treatments available if required. So exercise programs in patients with type 2 diabetes have been shown to lead to improvements in body weight, improvements in fasting glucose levels, reduced insulin resistance, reduced cholesterol, as well as improvements in blood pressure. And I'll end with this quote from Dr. Banting: "Sometimes the most trivial observations are accepted without question, whereas they may prove to be extraordinary in that they may lead to the solution of fundamental principles." So thank you so much for your attention. And if you have any questions, you can email me at megan.chenoweth@utoronto.ca. Thank you for your attention.